All right, guys, so let's continue the Revit. We still have some leftover for the Revit structure. We will try our best to finish that up today. So if you don't remember where to find, you guys can see my screen, right? Should be able to see. So if you don't remember where to find the tutorial, it's actually in the week 3 module, the Revit structure. So just go there. We have done items 1 through 5. So we're going to do the remainder from item 6. And I also have uploaded the latest model in this week 4 lab tutorial. If you open this one, the model for class exercise, just click here, you can download the Revit file, which is this file. This is what we have done last week. So we basically have programmed the reinforcement for this column and also reinforcement for one of the beam. Yeah, here. Okay. So now let's see the connection. Let's do the foundation cap today. All right. I'm going to add one here. So let me know if you are ready. Okay. All right. So now let's follow the tutorial. So let's go to structure. Once again, this is structure. Let's go to structure and go to foundation plan. And so we're going to just find the column that we have the reinforcement and the builder cap below that. It should be someone. Which one? Yeah, unfortunately, we just build the reinforcement for one of the columns, so we need to find it. Yeah, it should be this one. Okay, so we're going to build the cap underneath this one. So let's go to structure and go to isolated. We're going to use, yeah, this is a perfect cap for that. So let's just place it in the center. This is not visible, I know that. Computer is so slow. So I have this one built here, and now we're going to finish the reinforcement for this. All right. So the reinforcement of this cap look like this. Let me open the tutorial so you know what is the finish look like. So when we are done with the cap, it should look like something like this. All right, which means we have the rebars at the bottom, in both directions, and we also have some anchoring bolts by the end. Yeah, here we have the anchoring bolts to connect the cap with the column. Make sense? And once again, the reason we are building the rebars at the bottom is because concrete is good at compression but not tension. And for the cap, it's the same thing. The tension happens at the bottom of that. So we have two directions of that. Going up, the up is more for the shear, and also the anchoring bolts. For anchoring bolts is more structurally connecting the cap with the column. So this is how it looks like. Now, in order to build the rebars for the cap in two directions, we have to create a cross-sectional view in two directions. Make sense? So let's go back here and create a cross-sectional view for this guy. All right, so let's just to the foundation and go to the view. If you still remember how to create a cross-section view. So we probably need one here. And let's name that as, it should be, which one? Okay, so this is section 3. So let me rename that as cap cross 1. All right, and let's focus on the footing. So if you don't see that, we can just basically move that lower, because the level we're using is the foundation level, so we cannot see that, but now we can see the detail of that. And once again, we can change the scale, the view scale to the same 3/4:1. So now we actually see more details. And usually I prefer, that's personal preference, to use the thin line. So now we actually see this is the cap, this is the column, the rebars we built for the columns already. We're going to build the bars here. And do you guys still remember what is step 1 before placing the rebar? That's basically the cover, right? So we want to have the cover to protect the rebars. So once again, the first step is go here and go find the cover. So once again, you can define different covers, remember that. So, but I'm just going, you can define different covers, add a new cover, or reuse anything. So let's just use this one as the basis and name this one as rebar cover for footing foundation cap. And let's use 2, the same thing. And once it's done, so I have defined the cover for this way. Alrighty. And then let's go to structure and place the rebar. So go to structure and go to rebar. And let's find this rebar shape 17. And once again, if you don't see the preview here, which is very important, click the 3 dots, you will see the preview here. So let's find this rebar shape 17. Like this, all right? And let's go here. Now you see the shape of the rebar going this way. This is a parallel to the work plan, makes perfect sense to me. So I'm just going to play it here. And once this is done, remember this is only placing 1 rebar for me. So I want to change it to either fixed number or spacing. I think 4, the default one should be fine. All right, so that is done. Double click this one. Let's go back to the 3D view and check if it what I want. Where's the yes, here it is. Oh, it's only 1. Sorry, I didn't change that. Okay, so first of all, I prefer to use the box view. Remember how we do it? Select this component, use the control button, select this component. Let's say I just want to see these 2 things. And once you select them, you can basically use here, the view, section box, the box view. So select these 2 things and select the box view. That will basically highlight this area that I want to see. And just to make it easier, of course, I do not need this guy. I can basically also change the size of the box. Let me see. Oh, that's dirt. Okay, anyway. So now we see this one. And of course, if you want to see clearly, you can also add a concrete, right? So basically just select 1 concrete and then select head category. All right, it should be this head category. So now we can see clearly, the rebars are built. So something's wrong with this one. Let me go back to my cross-sectional view here. So I didn't change the layout correctly. So let me change it to maximum spacing 4. Enter. All right, so now this is done. All right, so I have the rebars in this direction. That looks good. Now I also need to place rebar in the other direction. Now I have 2 ways to do it. Number 1 is go here and go find my structure rebar, the same shape. And instead of going the parallel, I can say parallel to cover. No. Should be here, perpendicular. So now I place this one, you know what's going on, right? So basically the rebar you see here is going perpendicular to my current view. And that the big dot shows what, guys? The big dot shows where it's bending, right? So I should put it in this way. So that's one way of doing that. The other way is, of course, to create another cross-sectional view. So let's go to structure plan 00 foundation. And so we created one cross-section view in this direction, and we can definitely create another cross-section view in this direction, in the other direction. So let's say here, and let's go there. Once again, let's find the cap. Here it is. Okay, and now we actually build that way, right? So you see the little dot shows the where it bends. All right, so now I can do the same thing. Of course, I want to change the view scale to 3/4 to 1. Well, frame should be fine, but maybe one here. All right, so now I want to build my rebar, the same rebar in this direction. So I'm going to structure, rebar, same rebar, and I change it back to parallel. No, parallel to work plan. This is my current work plan. I can place it here like this, right? Okay, and then I can change it to maximum spacing, the same thing, enter. All right, let's take a 3D view. Let's go, we can use this one to see the 3D view. Now I see, oh, still it did not change. So let me just change it here. Maximum spacing 4 and enter. All right, so now I have this rebar of the 2 direction, but there's a problem. The problem is it's close. It's actually more clear to the in the cross-sectional view. So let me go there. Actually, the 2 rebars actually are overlying. They are going the same depths, which is not correct, right? So let's say this direction rebar actually goes through the rebar direction. So we need to adjust the depths of this rebar. It should be going either above that rebar or below that rebar. So we have 2 ways of doing that. One way is, of course, manually moving the rebar like this, okay? The other one is actually, we can just clear define the offside of the rebar. So let's go here, and in the property window, let me find it out. There it is. Edit constraints. So let me select this rebar, the set of rebar, and go find the edit constraints. Where's the edit constraint? Here it is. All right. So okay, hold on a second. Select this rebar, edit constraints. And we need to change the number. Where's the number? Here it is. Okay, so once I select this rebar, you can basically change the number here. That's actually the quantitative way to adjust the location. So let me just change this one to negative 1.75 inch. Now it moves up. Okay, now let me stop here and answer your question. So let me repeat this one. I don't think you followed me. Okay, so now the problem here is, guys, I have the rebars in this way. I have the rebar perpendicular to my current view in that way, but the rebar shouldn't go through my current parallel rebar, right? So I want to, my intent is to move this rebar, this side of rebar up, going above the perpendicular rebars. So one way is to just manually move them, but the more accurate way, precise way is to select the rebar here and go edit the constraints. And once this is done, okay, I select the wrong rebar. Hold on. I need to make sure I select not this set of rebar, this rebar. So I can use my type button to make sure I select this one. And once this is done, select edit constraints. Once you select it, you see the dots everywhere. So basically, when you double click dots, you will see a number. The number basically shows the exact number from this rebar to the bottom. Now I can just select this number and change it to the number I need from the design. So in this case, negative 1.75 inch. And once it's done, it basically will elevate this rebar, and I click finish. Now my rebar look like this. There's no conflicts anymore. So let me go to the 3D view of that. This is how it looks like. I don't know if you can tell, one bar is actually going above the other bars like this. All right, any question, guys, here? Okay, so this looks ugly. You know, I know these are lines. So we can actually show the actual size, the volume of the rebar to make it easier to see. So what we do is, let me see, select the rebar here, the box here, the rebar here, let me see. Select it here, and then let's go find something called the view visibility states. So in the property window of the rebar selected, I go to the view visibility states and go edit. And then I want to see view as solid. So I don't want to see lines, I want to see the solid. So I can basically, depending on which view I'm using. So I'm using this one, I think this one is fine. And I go, okay. Now it will basically show the actual size of the rebar. And the same thing apply to the other side of rebar. I can use the control button to also select the column bars, the column rebars I have. And once again, go to the view and change it to solid in my current view. So I think this is more clear to you, right? So it shows the bars going above that bars. Make sense? Questions, guys? You guys are so quiet today. Okay, so I'm going to move forward. And if you have a question, you can actually always review the videos, okay? All right, so now let's add the anchoring bolt. The anchoring bolt is this, you know, the one that is connecting my cap to the column. You know, we need 4 of them. So let's go back to here and let's add one and copy it to the 4 corners, okay? So that's my plan. Let me go to the cap cross view here and go to structure, rebar, and find the right one I need. So I'm going to use the one, let me see which one. Okay, so now we're going to learn how to sketch the freeform rebar instead of selecting the existing rebar. Okay, so let's go to structure rebar, and here you can see this function called sketch freeform, sketch rebar. So then we are just plotting this L-shaped rebar, let's say from here. Okay. Rebar, sketch, freeform rebar. No, hold on. There's another step showing that we need to select the correct work plan, otherwise it's not plotting. Rebar, okay, here it is. Not current work plan is near cover reference, should be this one. Sketch, no. Okay, so guys, I'm having this issue similar to what we had before. The rebar must go inside this foot, so I need to make sure that this is the work plan I'm plotting the free sketch rebar. I had this issue before. Let me see, current work plan, sketch rebar. Yeah, it should be this one. Okay. All right, and then click OK. So now I have this rebar. So let me do that again in case you didn't see what happened. So let me just say I want to free hand drawing some rebar here. And so I just go rebar and make sure it's selecting the current work plan and parallel to my work plan. So Revit understand that I'm trying to plot a rebar parallel to my current work plan. So I select this sketch rebar, but the first step is to select this work plan so it knows which work plan you want to use when you're having different work plans, okay? I'm selecting this one, everything's grayed out. So now I can plot my rebar, use this line. And so I'm just doing this one and click and release my button and come here. And then I go up like this. Of course, you can define, like I mentioned, you can use a keyboard to define the number here, but I'm just going to do this. So when this is done, I click OK. So I have this rebar in this way. Okay. And then I want to create a rebar that is mirroring this one. So instead of manually draw another rebar, the anchoring bolt, I can use a function called a mirroring. So I'm just going to select this one, and you see this one called a mirror. And you basically select the central line you want to mirror it. And then, boom, you have the other one. So let me do that again. Backspace. So I have this one, I select it, and once I select this anchoring bolt, I select this mirror, and then I pick the central line here, and it basically will send the bar over there. So now I have this two anchoring bar, and similarly, I can go to the other cross-sectional view of it. Now I see this bar is not in the right location, right? That's originally why we have that issue. So now I can basically move it manually to where I need. Of course, you can always use the define constraint. Remember that. But now, just for the sake of time, I'm just going to do this. So now I have the two things. Well, what we can do? I can basically select the two things and mirror that again, right? So I'm just going to find this one. Select this one and then go mirror. And so I basically mirror one. I can do the same thing to the other. Or I can go to the other, view and to mirror that. All right, so I'm just going to stop here, and I want to show you how it should look like. So we have the, hold on. They're here. Why the 3D view is not showing that? Did you guys see the anchoring bar? Oh, it's here. Okay, got that. Yeah, we need to also show the mass. So let's remember that. Let's select them and go to the view visibility and change it to solid. I have them. Okay, so I also need to mirror this guy. So I can select in the 3D view, mirror, select the central line. Somewhere, oh, it's impossible for me to find the central line. Okay, so anyway, you get the sense, right? So we need to go to the red cross section of view and mirror that. Or another way to do that is just control button, and it's kind of like what you dragging copies in Word document. It's just control button and select this piece and go in that. and you can change the dimensions of the constraints later. And let's change it to 3D view. Okay, and of course you can adjust that based on the constraints or manual adjust that. But this is pretty much how it looks like for cap. I can also render that to see how it looks like. All right. Questions, comments, guys? If no, I'm going to save it, and I can always check the recording. All right. So now the last step for the structural is the, oh, there's another thing I want to talk about. So let's go back to zero foundation. Let's say I'm done with certain, column or certain cap or certain cap. Then one thing you can do is to select this one, and I can use this. This is the copy function, and it basically just copy this for example, this column, and just select a corner of the column, and you can just move it to anywhere you want to copy it. And then you will have the exact same copy of the thing. This is very useful when you want to have the repetitive structures, and also if you want to have multiple levels of a building, you can always select the entire level and copy paste, so you do not repeat the design. Okay, so the last structural design we have is item 7. We want to also add reinforcement to a floor. Okay, so the reinforcement for floor look like this. We have these 2 directions, the rebars in 2 directions, and at the bottom and also at the top. Okay. All right, so let's go back to here, and let's go to item 7. So first, let's go to structure plan, 0 foundation. All right, here we are, and then go to structure, floor, and instead of clicking this floor directly, let's use the triangle and just say structural, floor structural. Okay, and now once we're here, let's use the rectangular box here to plot the floor. So basically we are telling the Revit that I know there's a floor, but it's actually my architectural floor. Now I'm going to tell you I also want this to be my structural floor. So that's different in Revit because for 2 reasons. Number 1 reason is, remember, Revit architecture and Revit structure used to be different programs. So they have different definitions, different codes. The other thing is when you are performing structural analysis, the behavior of architectural floor and the structural floor will be very different in your analysis. So when this is done, click OK. Rebar is placed outside of its host. Let's see what happened here. Let's go to structure. Okay, let's go to structure floor. Let's just use section of that. Okay, something's still going on here, but we have the floor here, which is the structural floor. Right. Okay, now let's place the reinforcement. The reason we are plotting the structural floor is, like I said, Revit defines the relationship. You cannot place reinforcement inside the architectural floor. It's more about the texture and finish. So we have to define the structural floor first to place the reinforcement. So let's go to structure and go to reinforcement area. Let me see. This one. All right. Now let's select the entire structure floor. It tells me no structural area reinforcement symbols family loaded. Do you want to load one? Yes. And then let's go find. Structural should be Structural framing, concrete, no. No. Okay, let me check. It's not showing in my tutorial because it was loaded before. I need to find it out. No structural text family. Okay, let me see if this is correct. Yeah, it's there already. It just gave me the warning because there's no host for it. But I don't know if you can see the reinforcement for the bottom of the floor is there. Let me just try to hide this category. I need to hide the architectural floor. Okay, let me use the wireframe view. You guys see that? You see the busy rebars there? That's actually the reinforcement created for the structural floor. All right, so I don't think I need to go over the entire thing just for the sake of time. So we are on item 7, and the item 7, the remainder of the item 7 actually talks about how you build the end of it. So let me show you that. So please go over these steps yourself. So basically the remainder of that is showing that we need to change, select the top rebar and change the hook tab here. Can anybody tell me why we need a hook here? Why it cannot be just a straight line, but where we have this bend, this hook here? Anybody? You guys are so quiet today. Okay, anyway, so basically when we have the loads on the floor will bend this way, right? So the upper will be, so for this one, we have a lot of tension. And so this hook is basically to, it's actually, if you see the internal force, there will be a force in this way. So this hook is going to hold it up. So we will have this hook here, and we also have hook for the bottom. So they actually use different angles, you will see from the tutorial, but that's actually straightforward. You just change the hook and you have the rebars here. And once it's done, the entire system should look like this. Like you have the rebar this way, rebar that way, at the bottom, at the top, with the edge to be the hooked shape and to hold the concrete. So that's pretty much how the structure design looks like. We talk about building the steel columns, the steel beams, and the concrete, and also the reinforcement for the beams, the column, and the foot and the floor. So that will cover a lot of the structural components. So I'm going to stop here. Once again, stop here for a moment. Any question, guys? You have been so quiet today. All right. So if no, let's move to this adding schedules and sheets. So this is a tutorial. We will skip this one, the structural analysis with robot structural analysis, because we have this software installed in the computer lab, but I don't want you to install that in your personal computer. It's a huge program and also requires really good computer. So one thing that you can do is to just check the tutorial and see how it works. Since the focus of this class is not structural analysis, so this one we just talk about you need to install an add-in in your Revit. Let me show you quickly here. So in the structure, there's a add-in. Oh, it's not here. Okay, so if there's add-in, then you will see that here it's called a robotic analysis. And you basically, what you do is to upload this model, convert this model into the format of this robotic analysis, and you define the load tab in your Revit. So basically I say this is area load or land load. I define it here and use this add-in and to send it to the robotic structural analysis. And once you click this one, you will see a progress bar. And once it's done, if you open the robot structural analysis program automatically, so it will show this one. And now you can see only the structural components will show up here. Architectural components wouldn't show up in this program. So that's why we define all the reinforcement, everything, okay? So you will see here, and the loads are defined already. And the next step is, if you know finite element analysis, you know you want to define the constraints, right? So we basically define, usually we define all the foundation as fixed, which means they don't have any movement, they don't have any deformation. So we basically fix them, and then you basically define the boundaries, the border constraints, and you basically run the analysis. This is FEA, finite element analysis program. Just take us a while to tell you to give you the deformation calculation, and also give you the strain distribution, like the internal force of different components, and also the stress analysis, like for different components, what the stress look like. So this is very useful for structural analysis, but this class we'll just talk about how to send it to the robot structural analysis. Revit is able to do it. That's something you need to know. And you can check some videos for item 9. So we will remove that. So the next, the final item for the structural tutorial is number 8, adding schedules and sheets, okay? So let's go back to our model. Let me just unhead everything. And let's go to item 8. So let's go to our view and go to schedules here, and go use the lower part and go schedule the quantities. All right. So here, since it can generate the schedules for different categories, different purpose, we focus on structure. So let's just go. We can uncheck architecture and select a structure. So everything will be related to my structure. And let's find this structural foundations. Here it is. All right. And then let's go. Of course, you can change the face. This is more about the new construction. Okay, so let's go OK. And let's say what fields or what columns we want to see. So let's just select maybe area, assembly code. You can use the control button, select multiple. Let me see elevations at the bottom, elevation at the top, foundation thickness, estimated reinforcement volume, foundation thickness, and maybe the hue length. All right, and send them there. So this is still defining the column of that. So when this is done, you basically have this list of different the reinforcement of our foundation. And similarly, I showed you guys last time, you can also sort it, group it, whatever you need. Okay. So once this is done, you will be able to see it here. You know, schedule. You will see this new line, schedule the foundation quantities. So you have it here. This is how you create a schedule. So let's say you want to create a schedule for your columns, for your beams, and for your footing. You can create multiple of them, and they will all be listed here. Okay. So now let's create a sheet. The sheet is actually the final drawing, right? So let's go to the view and go to the sheet. Here it is. And then let's select, you know, what kind of titles we need. Of course, you can rename one or load the existing one. Okay, and this is the size of that. By default, it only provides this one size, but it can definitely load different format of sheet. So once you load it, you will notice that this one shows A101. A represents architecture. Okay, so for drawing size, we have architectural, structural, MEP, and also site drawings. Okay, so this one by default it gives us. If you want to generate other sheets, you can just load different sheets template. But this one, we have this one, and you can basically just, you know, rename that. Let's see, Eric Do Engineering LLC. All right, you can see the product name. You see RVT class. And of course, you can just define everything here, change everything here. And now we can move the views. So the views are presented here. For example, I have this 3D view, but 3D is probably too much, but you can just drag it here. It's too much, it's too big, okay? So we want to use the crop the view. Let me just drag it again. Let me drag some cross-sectional view first. Put it here, all right? And more cross-sectional view. All right, so you can just basically drop whatever you need, and you know, if something's too big, like this one is much bigger than my, it's much bigger than my. Well, this is not a good example. But once you have this one, of course, you can make it smaller. Okay, you can use the crop view function here to get just a portion of that. It should be modify view. Let me see, where's that? Okay. Cannot find it. Why? Okay, I need to find it out, guys. So I will let you guys know later. It's supposed to just once this is dragged here, it should give me this crop view. Okay, yeah, let me do some research. I forgot where to find the crop view. Anyway, so there's a tool. Once you try to drag, you know, here's the thing: you can just simply drag whatever floor plan, ceiling plan, structure plan here, and put them in this sheet. But if something is too big, there's a scale tool, and there's also a crop tool to show just a part of that. I just kind of forget where it is, but I will figure it out and let you guys know later. All right, so this is pretty much what we have for the structure, and we will have to move to the MEP so we can get rid of Revit. So before that, any question, comments about this Revit architecture, Revit structure so far? And this sheet, you can also see once you create it, you definitely see all the sheets here. So when you save this Revit file, this RVT file will include all the quantity schedules and the sheets you created. All right, and also the render the pictures, the walkthrough videos, everything will be stored in a single file. That's the beauty of Revit. All right. If there's no more question, let's take a brief 5-minute break. I need to use the restroom quickly. All right, see you guys in about 5 minutes.